Good day, all children. This is Rajashree Dilip from Science Academy. Today, we are going to discuss about the topic Gravitation, Part 1. This topic belongs to Class 9. Let us move on to the topic, children. Topics to be discussed: Gravitation, Universal Law of Gravitation, Importance of the Universal Law of Gravitation, Free fall, to calculate the value of G, motion of objects under the influence of gravitational force of the earth, mass and weight, weight of an object on the moon. What is gravitation? Gravitation is a phenomenon of attraction between any two objects in the universe. The objects may be terrestrial, that is, objects which are on earth, or celestial, which are in outer space, such as stars, planets, satellites, etc. The objects may be of any shape, size, or mass. Next, we are going to discuss about Newton's universal law of gravitation. This can also be called as Newton's inverse square law. This law states that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. Consider two objects A and B of masses m and m respectively. Let d be the distance between their centers. If F is a gravitational force of attraction between these objects, then according to Newton's law of gravitation, the force between two objects is directly proportional to the product of their masses. That is, F is directly proportional to capital M into small m. Also, F is inversely proportional to d square. Therefore, F is proportional to capital M small m divided by d square. Therefore, F is equal to G into capital M small m divided by d square, where G is a constant and is known as gravitational constant. Value of G will be equal to 6.67 into 10 to the power of minus 11 Newton meter square divided by kilogram square. G is nothing but universal gravitational constant. Importance of the universal law of gravitation. The universal law of gravitation given by Newton has explained successfully several phenomena. For example, the force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, the tides due to the moon and the sun. Next, we are going to discuss about free fall. Every body on earth is attracted by earth towards its center. Therefore, every object, when free, falls towards the earth due to the gravitational force of earth. So, all objects falling towards earth under the action of gravitational force of earth alone are said to be in free fall. Formula for F equal to G into capital M small m divided by r squared. F is equal to m into G. According to Newton's second law of motion, force is equal to mass into acceleration due to gravity. Therefore, G capital M small m by r square will be equal to mg. Therefore, finally we are getting the value G is equal to capital G capital M divided by. To calculate the value of G, that is acceleration due to gravity. The value of acceleration due to gravity can be calculated from the relation between small g and capital G. That is, acceleration due to gravity G is equal to capital G, gravitational constant, into capital M, mass of Earth, divided by capital R square, radius of Earth. So, mass M will be equal to 6 into 10 to the power of 24 kilogram. Diameter of Earth will be equal to 12.8 into 10 to the power of 3 kilometer. That is 12.6 into 10 to the power of 6 meter. Therefore, radius will be 12.8 into 10 to the power of 6 divided by 2. That is equal to 6.4 into 10 to the power of 6 meter. Gravitational constant capital G will be equal to 6.7 into 10 to the power minus 11 Newton meter square divided by kilogram square. Therefore, the value of G, acceleration due to gravity, will be 6.7 into 10 to the power of minus 11 into 6 into 10 to the power of 24 divided by 6.4 into 10 to the power of 6 the whole square. Therefore, finally we are getting the value G is equal to 9.8 meter per second square. As the value of G is equal to 9.8 meter per second square, the planet could be Earth. Next, I am going to explain about motion of objects under the influence of gravitational force of the Earth. We have learned that all bodies, big or small, hollow or solid, fall towards Earth with a constant acceleration due to gravitational pull of Earth. This acceleration is called acceleration due to gravity and is represented by small g. The three equations of motion derived earlier in chapter 1, motion, for bodies moving with uniform acceleration, can be used to describe the motion of freely falling bodies. In the general equations of motion, we replace acceleration small a by acceleration due to gravity small g. Then the equations will be V is equal to u plus gt, h is equal to ut plus half gt square. V square minus u square will be equal to 2gs. Mass and weight. The mass of a body is defined as the quantity of matter contained in the body. It is represented by the symbol small m. The SI unit of mass is kilogram kg. What is weight? The weight of a body is defined as the force with which the body is attracted towards the center of the earth. It is denoted by capital W. W will be equal to m into g. The SI unit is Newton, capital N. Weight of an object on the moon. The weight of an object on the moon is the force with which the object is attracted towards the center of the moon. That is, weight in moon will be equal to 1/6 of weight in earth. Let us consider ME and RE is the mass and radius of the earth. MM and RM is the mass and radius of the moon. We know the relationship RE will be equal to 4 into RM. ME will be equal to 100 into MM. Weight of the body of mass M dash on the surface of the moon is Wm will be equal to Fm will be equal to capital G M dash divided by Rm square. Therefore, weight of the body of mass M dash on the surface of the earth is We is equal to Fe is equal to G M dash divided by Re square. That is G into 100 mm into M dash divided by 4 Rm the whole square. Therefore, finally we are getting 100 divided by 16 Wm. That is approximately 6.25. So we can take it as 6. Therefore, weight in moon will be equal to 1/6 of weight in earth. I hope you would have understood all the topics which we have discussed in this video. Thank you all children.